All right, yesterday's lesson, we introduced a bunch of discontinuities, and these included vertical asymptotes, like this red line here. I'm going to kind of trace over it in orange. They included horizontal asymptotes, and in both those asymptote cases, they represent lines that kind of don't exist on our graph. Notice how our graph will go up and kind of bump up against both those asymptotes, but never quite hit it. And in both cases, at those lines, it kind of jumps across to another extreme example. And then that third type of discontinuity we saw was a hole, where there's not necessarily an asymptote here, but the function does not exist. So we looked at a few different ways to find these graphically and algebraically. Today, the purpose is to really hone in on the graphical aspect of it, because that is going to give us the most help during our test. So you'll notice in these notes, I've actually just kind of listed a bunch of the instructions. So both vertical and horizontal asymptotes can be found the easiest through graphing. So we got 4 steps here in order to get these graphed and located. It's important to note that there are ways to find these through algebra, but it's not going to be the focus during this course. That will come up in Math 4 and future classes. So you got some good exposure to it yesterday, but let's focus on the graphing today. So for everything, we're going to graph the function in Desmos. We're going to inspect the graph and look for those asymptotes. Then we got to check them. And yesterday we handled vertical, where we typed x equals, and that created a nice vertical line in our graph. If I typed in x equals 5, notice how it showed up a vertical line at 5. Okay. For our horizontal asymptotes, we're going to type y equals, and we can test them out that way. If I type y equals 2, it creates a horizontal line at 2. Then we just want to confirm that the new line does not intersect the graph. Let's try this out. I'll walk through the first one then, and if you want to pause your screen and try this on your own already, I highly encourage that. But at the very least, make sure you're matching me. So we have this first function here, f of x equals 2x minus 1 over x plus 2. So let's throw that into our graph. F of x equals, and it's always helpful to throw that fraction first, 2x minus 1 over x plus 2. And we might need to zoom out a little bit to kind of see what's going on. And it looks like if I'm trying to find my vertical asymptote, I'm kind of seeing that roughly right here. And so I'm just going to make a quick guess and check and say, hey, that looks like it's probably at -3. So let's say x equals -3. Throw that on there, and you can see that that is not correct. I have an intersection here, so that doesn't work. What I want to do is perfectly hit that seam there. So I'm going to slide it over to the right a little bit. Let's go x is equal to -2. And you can see that indeed, if I scroll up higher and higher, my graph never intersects my asymptote. And if I scroll lower and lower, we can do kind of a final check to see, all right, when I click on the graph, do any gray dots show up as I zoom out? And there's nothing for intersections there. So I'm happy with that asymptote at x equals -2. I'm going to kind of go and mark that on my sheet here. We have a vertical asymptote at x equals -2. Now we also want to find that horizontal asymptote. So I'm going to turn this one off and focus on this horizontal asymptote. Now we're trying to find that line that runs in between our graphs horizontally. Okay, and roughly, let's say that looks like it might be at y equals 3. Let's try that out. Test out y equals 3. That looks like it's too high. I have to lower it because we have that intersection there. So I'm going to drop that down and get y equals 2. And that looks like it's nice and good where we're not intersecting our graph at all. So our horizontal asymptote is at y equals 2. So go ahead, try example 2 on your own. Pause the video, try it real quick, unpause it to check your work, and we'll come back and compare. All right, so I have it graphed in Desmos now, 1 over 3x squared plus 3x minus 18. And it looks like upon inspection, there's actually 2 spots right here and right here that I have vertical asymptotes at. So let's try both those out. It looks like this first one is probably at a value of -3, and the next one looks like it's at a value of 2. So let's go x equals -3. That looks like we hit it nice and clean. And let's go x equals 2. That looks like we hit that gap nice and clean as well. So our two asymptotes are at -3 and 2. Let's write that in. X equals -3, x equals 2. Then for our horizontal asymptotes, let's kind of clear our vertical one so we have a nice clean look at it. It looks like we have right along the x-axis, we have a spot where our graphs never cross. So let's try that out. That would mean that we have a y value of 0. And I'm going to change the color there just to make it a little easier to see. I'll change it to red. It doesn't look like we ever intersect that. And again, we can check that by clicking on that, one of those graphs, and seeing if we have any gray dots show up, because Desmos will highlight those key points. Looks like we have a couple in here, but if we zoom in, those are not intersections that it's highlighting. Those must be other key features of our graph. So we're good with y equals 0 for our horizontal asymptotes. Now, the other thing we talked about yesterday was points of discontinuity, and these are holes. If there's a hole showing up, it is not an asymptote. Notice that those are going to be different things. And if I go back to that image we looked at earlier, the hole is right here. Notice how it's not an asymptote. It's just an instant in time that doesn't show up. So if there is a hole, it's not considered an asymptote. Or a point of discontinuity is also not considered an asymptote. To find these, we're gonna have a little bit different process, and normally we'll be given some options to check through. Okay, it's difficult to find these just on inspection, so usually we'll have like a multiple choice option, and I'm going to kind of mimic that in our notes and practice today. So we graph the function Desmos. We're going to test each possible point. We can do this two ways. We can either click and drag along our graph to test, or we can add a table of values and play around with our x values. When we see the word undefined as our output, that's going to tell us we have a hole in that function. So let's try this with the first one. And we know based on yesterday's work, we're going to have a hole at x equals 3 because it has a factor that shows up on top and bottom there. But let's try it out in Desmos. So going to create my new graph. I have on top I have x minus 3, on bottom I have x plus 4 times x minus 3. And if I look here, again, I'm not concerned about the vertical and horizontal asymptotes right now. I'm worried about the holes. And I'm trying to see, all right, is there a hole at -4? Is there a hole at -3? Is there a hole at 3? And is there a hole at 4? Well, the first way we can do this is click and drag. We can literally click and drag our mouse to kind of see, all right, what is my function value as I approach that number? If I look at -4 here, I'll never actually be able to hit it, but it's not a hole. It's an asymptote, right? So -4 is not a hole. This one is an asymptote. So we are going to ignore it, right? But it's a good thing to put kind of that note in there. And if I look at -3, which is right around here, notice how my x value is getting closer and closer to -3. And as I hit -3, I have a y value of 1. So the function does exist there. So I'm going to kind of cross that one out. That one does exist. We're fine there. If I go back to Desmos, and now I'm testing out the point 3, okay, there's 1, there's 2. As I click and drag and reach 3, you'll notice that my graph turns into a hole, or my cursor turns into a hole, and the graph goes undefined. So that means we do have a hole there. Our function doesn't exist at 3. So this is where our hole is. I'm going to put a circle on it and kind of make a note. Hey, this is where our hole is. Or point of discontinuity. And the last one we can check out is 4. If I click and use that cursor, okay, at the point 4, if I hover exactly right, okay, I do have a value. So that is not a hole in that case. I can cross that one out. Okay, the other way we could have tested this, and this might move quicker, is if you click this wrench sign for settings and add a table to our function, we can type in the x values of all those points. So we were interested in -4. It's undefined, and so we got to be smart enough to know that that's an asymptote there. Okay, -3, that gives us a value. Notice how that point just showed up on our graph. Okay, and then we have 3. This one's also undefined, and I'll delete these two real quick just so we don't have it in the way. 3 is also undefined, so that means we have our hole there, and 4 has a value that shows up, so that is not a hole. All right, pause your screen, try this on example 4 before you go into practice, and once you unpause it, we can kind of check my work. All right, so I got it graphed, and we are checking the values 2, 1, -1, and -2. So what I'm going to do is I'm just going to throw these into my graph or my table real quick. 2, 1, -1, and -2. So obviously 2 and 1 are not holes; those show up. And if I kind of click and drag my cursor, I can see that hey, at those points, I have values for my output, so they are not holes, they're not discontinuities. But if I look at -1 and -2, these are where we're undefined. So the one thing we want to do is make sure, all right, which one is my asymptote, which one is my hole? If I look here at -1, that looks like it's an asymptote. If I click and kind of drag on my cursor at -2, however, let's see if I can hone in there exactly. Boom, we got our spot where we're undefined. We have a hole there. So in this case, I know that x equals 2 isn't it, x equals 1 is not it, x equals -1 is an asymptote. And so our answer there is x equals -2. That is our hole.